You think an atom is a tiny solar system, a little nucleus, little electrons, things going around other things. You picture structure, you picture parts, you picture inside. That picture feels obvious, it feels earned, it feels harmless. It is wrong. You imagine that if you could zoom in far enough, reality would finally sit still, that the confusion is just scale, that the rules don't change, only the size. They do change completely. Inside the atom, the words you rely on stop behaving. Position becomes suspicious. Motion becomes unclear. Even as it starts to wobble, you think looking closer gives you more detail, more certainty, more truth. Here, it does the opposite. The closer you look, the less there is to hold on to. Not metaphorically, literally. This is not because atoms are complicated, it's because your picture of reality is. And the atom is where that picture quietly collapses. You expect an atom to have an inside, not metaphorically, literally. You imagine peeling it open the way you would a machine, layers, components, smaller things doing familiar jobs. If you could just zoom in far enough, the mystery would settle down. This expectation feels reasonable. It comes from every successful explanation you've ever trusted. You open a watch, you find gears. You open a computer, you find circuits. You open a cell, you find machinery. So you assume the atom works the same way, a container with contents. This is the first mistake. The idea of inside already smuggles in a picture of space divided into regions, a picture where things occupy places, and places exist independently of what's in them. You don't question that picture, because it's never failed you before. At human scales, it works too well. But physics doesn't care where your intuitions came from, only where they break. When you say inside the atom, you imagine a smaller room inside a larger one. You imagine boundaries. You imagine hidden furniture waiting in the dark. This is wrong. Not because we lack better microscopes, not because atoms are too small, but because the question itself is malformed. An atom is not a box with contents. It is not a tiny object with an interior waiting to be explored. It is a set of constraints on what can happen. That sentence should feel unsatisfying. Good. It means the intuition is still resisting. You are still expecting discovery to mean uncovering something that was already there. You are still picturing reality as a collection of objects stacked inside other objects. But atoms don't reward that way of thinking. They punish it. When physicists tried to locate the stuff inside atoms, they didn't find smaller beads or spinning dots. They found that the very act of asking where was already too much, not too advanced, too naive. The atom doesn't hide its contents. It refuses to define them. There is no moment where the fog lifts and the picture sharpens. There is only the slow realization that the picture was never appropriate. You wanted a thing. You got a rule. You wanted an interior. You found a boundary on meaning. And this is only the first crack. Because once you let go of the idea that atoms contain things in the usual sense, you are forced to confront a deeper problem. If there is no clear where inside the atom, what does it even mean to say that something exists there at all? You assume the electron is somewhere. Maybe you don't know where, but somewhere. This feels unavoidable. Existence, to you, has always meant location. If something exists, it occupies space. If it occupies space, it has a position. If you don't know the position, that's ignorance, not a crisis. This logic has never betrayed you. Until now. Inside the atom, the electron refuses to cooperate. Not because it's hiding, but because there is no position to uncover. This is the moment where intuition quietly collapses. You are tempted to say, the electron is there. We just can't measure it precisely. That sentence sounds careful. It sounds scientific. It is wrong. The problem is not technological. It is not disturbance. It is not clumsiness. The electron does not carry a definite position around, waiting to be revealed. There is no tiny dot tracing a tiny path between measurements. When you are not looking, the electron is not somewhere else. It is not anywhere in the way you mean the word. This is not philosophy. It is enforced by experiment. Whenever physicists tried to trap the electron into behaving like a located object, it responded by breaking the very idea of location. The more tightly you demand where, the less meaningful the answer becomes. You might protest, surely it must be somewhere, or it wouldn't be real. That protest assumes reality owes you a picture. It does not. What replaces position is not vagueness. It is structure without location. The electron is described by a pattern, not a place. A pattern of possibilities, a rule assigning weights to outcomes you might observe. This is where language begins to betray you. The word electron sounds like a noun, a thing, something you could point to. But inside the atom, electron behaves more like a verb, or better, a constraint on what can happen if you try to force a point. You are not missing information. There is no hidden coordinate you failed to access. The question, where is the electron right now, has no answer. Not an unknown answer, no answer. This is not because physics is incomplete. It's because the question assumes a world made of located objects, and that assumption no longer survives. Once you accept this, unease sets in. If the electron does not have a position until you demand one, and if demanding one changes what exists, then location is not a property. It is an outcome. And that should bother you, because position was never supposed to be optional. It was supposed to be the bedrock. But inside the atom, the bedrock dissolves. And if location is no longer fundamental, then motion, the act of changing. Location is about to become something far stranger than you expect. You think motion means travel. Something here, then later there. A path connecting the two. Even when things get small, you keep this picture. You just shrink the path. You imagine finer curves, tighter orbits. Inside the atom, that picture fails completely. If the electron has no definite position, then it has no trajectory, no continuous line through space, no story you can tell frame by frame. This is not a limitation of measurement. It is a collapse of the concept. You might try to rescue the idea by saying the electron is moving around in a cloud. This sounds reasonable. It sounds like compromise. It is still wrong. A cloud suggests hidden motion, tiny paths blurred together. But there are no paths to blur. The electron does not travel from one point to another between observations. It does not wander. It does not orbit. What changes is not where it is, but what can happen. This is where motion stops being geometric and becomes structural. Inside the atom, change happens without passage. Outcomes shift without anything crossing space to make them shift. The system evolves, but nothing moves in the ordinary sense. This is deeply uncomfortable. You rely on motion to explain causation. You imagine influences being carried from place to place. You imagine continuity doing the explanatory work. But here, continuity is optional. The electron's motion is a change in the pattern that governs measurements, a reshaping of possibilities, not an object sliding through space. If you insist on asking, so where does it go in between? Physics answers, there is no in-between of that kind. Time still passes, predictions still change. But there is no cinematic sequence behind the scenes, no frames, no hidden movie. This is not because reality is fuzzy. It is because your demand for a movie is misplaced. You are used to explaining change by imagining something moving. But the atom changes without transporting anything. This is why classical pictures keep failing. They all assume that motion is primitive. Inside the atom, motion is derivative, secondary, a bookkeeping convenience that only applies when outcomes are forced into space and time. And this creates a problem you cannot ignore. If nothing is moving through space, if there is no underlying trajectory, then what exactly is being conserved? What carries cause to effect? The answer will feel even more unsettling, because the next intuition to collapse is the idea that observation is passive, that measurement simply reveals motion that was already happening. It does not. You think measurement is harmless, a glance, a question politely asked. You imagine reality doing its thing, uninterrupted, and measurement simply checking in. This belief is so deep you rarely notice it. Seeing feels passive. Knowing feels innocent. Inside the atom, this belief becomes indefensible. When you measure, you are not uncovering a property that was already there. You are not lifting a veil. You are not peeking behind the curtain. You are forcing an answer. And the system complies by abandoning all the other answers it could have given. This is not metaphor. This is operational. Before measurement, the electron is not quietly carrying a position, a momentum, a path. It is carrying rules, limits on what outcomes are allowed and how likely they are. The moment you measure, those rules are rewritten, not updated, not refined, replaced. You ask for position and you get position, but you do not get it for free. In exchange, you lose the right to talk meaningfully about momentum. You lose continuity. You lose the story you thought was running underneath. This is not because measurement is violent. Even the gentlest possible interaction does this. The problem is not disturbance. It is definition. Properties like position are not sitting there waiting. They are not attributes of the electron alone. They are attributes of the interaction. You cannot separate what is measured from how it is measured. There is no what it really was hiding behind the apparatus. This is the point where language breaks. We say measurement collapses something as if there were a physical thing crumpling. But nothing collapses. What disappears are alternative descriptions you can no longer justify. After a measurement, you can speak clearly but narrowly. Before measurement, you could speak broadly but abstractly. You don't like this trade. You want both clarity and completeness. You want sharp answers without giving up the bigger picture. Nature does not offer that deal. You may try to retreat to a safer belief. Surely the electron had those properties. We just can't know them simultaneously. This retreat fails. If those properties existed simultaneously in any meaningful way, their consequences would show up. They do not. The universe is not hiding its homework. It is refusing the assignment. Measurement is not a window into reality. It is a boundary where reality is forced to choose a face. And once chosen, all other faces vanish, not because they were false, but because they are no longer allowed. This is where the consequences become unavoidable. If observation participates in what exists, if properties are not settled until demanded, then the idea of an objective, observer-independent interior is already gone. What remains is not mystery. It is precision without comfort. And now you are ready for the next failure, the realization that nothing is actually missing from the theory. What is missing is something else entirely. At this point, you start to suspect a gap, a missing piece, some deeper layer we haven't found yet. This suspicion feels responsible. It feels like scientific humility. It is also a misunderstanding. The discomfort you feel is not coming from incomplete physics. It is coming from complete physics colliding with incomplete language. You keep asking for things the theory never promised to give. You ask what the electron is, what it's doing, what it's really like when no one is looking. These questions sound reasonable. They are grammatically valid. They are physically ungrounded. The formalism works relentlessly. It predicts spectra. It predicts chemical bonds. It predicts stability itself. What it refuses to do is provide a picture that fits inside your old nouns. There is no missing mechanism, no hidden clockwork, no suppressed variables waiting to be discovered that would restore familiar imagery. This is not because physicists lack imagination. It's because every attempt to add such imagery adds contradiction. When you try to force electrons into being little objects with secret properties, the math pushes back. Hard. You get predictions that are wrong. You get violations of conservation. You get worlds that do not resemble the one you measure. So the theory learned a strange discipline. Say only what can be said. Predict only what can be tested. Remain silent about the rest. This silence is not ignorance. It is restraint. The mistake is thinking that explanation requires visualization. That understanding requires a story with characters and trajectories. That demand comes from macroscopic habit, not microscopic necessity. Your everyday language evolved to track chairs, stones, and predators. It did not evolve to describe entities that do not possess definite properties between interactions. So when you ask for a picture of the electron itself, you are asking language to do a job it was never built for. Nothing is hiding behind the equation. Nothing is missing. What is missing is a way of speaking that does not smuggle in classical assumptions. The equations are not a shadow of something more real. They are the most honest description available. This is why the frustration never resolves into clarity. There is no final mental image waiting at the end. There is only a gradual shedding of demands. You stop asking what the electron is like. You start asking what the theory allows you to say. This feels like a retreat. It is actually an advance. Because once you accept that reality is not obligated to match your metaphors, a different kind of understanding becomes possible. One that does not pretend the confusion will go away. And this is where Feynman's warning enters, not as a slogan, but as a precise diagnosis. You have heard the line, nobody understands quantum mechanics. It is usually delivered with a shrug, as if it were an admission of failure. That is not how Feynman meant it. He was not confessing ignorance. He was rejecting a specific demand. Your demand. The demand for a picture that behaves. Feynman understood something uncomfortable. The theory is not confusing. Your expectations are. Quantum mechanics does exactly what it claims to do. It predicts outcomes with brutal accuracy. It never contradicts itself. What it refuses is narrative comfort. When Feynman said we do not understand quantum mechanics, he meant we do not possess a classical story that sits underneath it. And no such story is required. Understanding, in the everyday sense, means being able to imagine what is happening when no one is looking. A mental movie, a causal chain you could, in principle, sketch. Quantum mechanics denies you that movie, not because reality is chaotic, but because the demand for a movie is an extra assumption. Feynman's warning was surgical. Stop asking for what the theory does not offer. He did not say accept mystery. He said stop adding fiction. Every time you try to visualize an electron as a thing moving through space, you are not clarifying the theory. You are replacing it with something else, something worse. The equations are not symbols pointing to a hidden mechanism. They are the mechanism. This is why Feynman was allergic to interpretations that promised intuitive rescue. He knew the cost. They smuggle in classical imagery, and in doing so, quietly reintroduce the variant. Confusions the theory removed. Feynman's stance was not mystical. It was disciplined. Say what you can calculate. Calculate what you can test. Refuse to pretend you have more. This is not intellectual surrender. It is intellectual hygiene. And once you take that warning seriously, something shifts. You stop asking what the atom looks like on the inside. You stop demanding a reality that behaves like an object. You begin to suspect that the deepest mistake was assuming reality had an inside at all, which leads to the final step, the one that removes the last intuitive crutch. The idea that everything must be made of things. You began with a simple assumption that everything must have an inside, that if you kept looking closer, you would eventually reach the real furniture of the world. Smaller things, doing clearer things, in tighter spaces. The atom quietly dismantles that expectation, not by hiding its contents, but by revealing that the question was misplaced. There is no inner stage where reality performs when no one is watching, no miniature theater beneath appearances. What you find instead are limits on description, on prediction, on meaning. The atom is not a container. It is not made of parts behaving badly. It is a boundary where certain questions stop making sense. This is the final discomfort. Reality does not seem obligated to be built from things at all. At least not things with identities, locations, and stories that persist independently of interaction. What exists are relations, constraints, regularities in what can happen when you intervene. You do not uncover reality by peeling it open. You encounter it by pressing against its limits. The closer you look, the less it resembles an object, and the more it resembles a rule. This is why the atom never gives you a picture. A picture would lie. It would suggest an interior where none exists. It would promise a stability reality does not offer. Feynman was right, not because the world is strange, but because it is precise in a way intuition is not. The atom is not weird. Your expectations were oversized. There is nothing beneath the atom waiting to restore comfort. No final layer where things snap back into place. Only a quiet, unsettling realization. Reality does not need to make sense the way you want it to. It only needs to be consistent. And somehow, that is enough to build stars, chemistry, and thought itself. Not from things, but from limits. And once you see that, you stop asking what's inside the atom. You start asking what kind of world could exist without an inside at all.